Now, what's going to happen is, in our last class, we were done with type 3 of the functions, which was many to one function, and the domain is given as a range. In today's class, what we're going to do is, Parsa, if you saw in the last class, was that over here, I said when it was a many to one function and the domain itself was given as a range of values, and you had to find the range of that particular function. There was one step in which you had to check whether h lies in the given domain. H is what? The x coordinate of your turning point. Now, if it lies in the given domain, that means what? That you can, utilize your minimum point and find your minimum point, whatever. But there is, it's very, you can say it's highly likely that maybe it did not. Like, for example, a type of question came where it did not lie in the given domain. That could be a, a very greater possibility as well. What if it doesn't lie in the domain? And that leads us to, our final type of your domain and range finding is that what if your function or your turning point does not lie in the given domain. So we can just call this as type A 1, type 3 1, sorry. And now there's a highly likely, possibility that your turning point does not lie in the given domain. Then what will you do? Let's see. So, for example, if the same question is given to you, the entire same question is given to me. I'll just copy it down over here. So many to one function, everything is there. All right. And we'll just say that, this is type 3 again as well. But there is a highly likely chance that, there could be the range is not in your, the turning point is not in your given domain. That could be a case as well. What will we do then? That's what we're here to see. So the rest of the steps
So
are
don't
going
you
to,
like draw like an asymptote at like the points of the turning point?
you do, but okay, yes. But that is, I would say that is a bit more, um, you can say a bit more extensive. What we're going to try and do is we're going to try and make sure that we, do not utilize a lot of time on this, because usually this will not be a more than um, maximum 5 mark question. It won't be more than that. Should not be more than that. Okay. What if your given domain, person, is like this? For example, what if your given domain is 4 and 6? All right. That means that your um, function, the turning point, the x coordinate of its turning point does not lie in the domain. All right. Turning point does not lie in the given domain. Clear? Now, what if your turning point does not lie in the given domain? What will you do? It is extremely simple. Again, you're just going to have to, what you may call, try and put in your values of your domain into the function again. It's just as simple as that. Your maximum values into your function again. Like, for example, this is going to be the case again. Oh, so what's going to happen? I'm just going to put in my values again, which is going to be like this. So my domain was 4 and 6 now. And I just need to put my extreme values into my function again. And that is going to give me my values of the domain, which is going to be like this. Wait. Mhm. We're going to put our extreme values into the function again. And what is that going to do? Is that is simply going to make sure that our values, we get our values of our range. And how are we going to do that? Is just as simple. So for example, it's going to be f of 4 is going to be 4 squared minus 6 times 4 plus 8, which is going to be equal to f of 4 is equal to, what should be the answer? 4 squared is 24 minus 6 times 24, I think 8 or something like that. No, that is 16, sorry. This is going to be 16. Why did I do 24? 16 minus 24, 8 minus 8. Okay, so this is 0. Clear, person?
Yes.
And once you put your extreme values into your function, you're simply going to get what you may call the extreme values of your range as well. Where does your range extend to and from where? Clear? Knowing this, what's going to happen is that I'm simply going to, if I put my, this we draw the graph again. It is just simply going to be, this time around, I'm going to, wait. So this time around, your range was different. Your range was from 4, from like around 4 over here somewhere. Okay, let's just say, okay, 4 was where x is equal to y is equal to 0. So obviously 4 is going to be here. 4 was a intercept. And let's just say that, 6 was here. So if we were to draw our graph, let's just try to expand this guy. So it would be, look something like this. And whatever it was, your x-intercept we already know is 4. But how do we know that? Because when you put 4 as x, y becomes 0. And we'll just imagine that this is, let's just say 6. And what is going to happen? That your graph is going to be, your graph only allows values till here, which obviously is going to have some sort of x values as well. So this is going to be over here, and obviously it's going to be over here. So whatever was the value over here, which was 8, this was already 0. This was your range. Clear, Pasha?
Yes.
Perfect. Hmm, keep it till here. All right. Now let's continue. So what's going to happen now is that we're going to try and see what are your values. Oh, okay. Sorry, we're done with this. That you put in your extreme values of the domain into the function, and you're going to get your idea. Clear? Any issues with this person?
No, Mr. No issues.
Perfect. That is perfect. Just give me a moment. All right. So now let's see. What are we going to have is that first off, next up, what we're going to have is that sometimes the function is a bit unique. These functions were very generic and very stereotypical. Your daily life functions, quadratic and stuff. So it's quite easy to, find out their domain and ranges because it's kind of like one step way of doing it. But some functions are a bit unique in the sense that, they are what you may call, um, what you may call, like, for example, like a trigonometric function. It's very unique. How so? Is that, for example, it is going to be y is equal to sine x, right? And this is going to be equal to 0 is less than equal to x. This is your domain. For this is your function, y is equal to sine x is your function, and this right here is your domain. Because we've already discussed that your domain is always given. And oh, we forgot to write down the domain of the previous function. So in your previous function, the domain was that f of x was greater than equal to 0 and less than equal to 8. That was your domain. That was your range for the previous function. All right, now let's continue. What's going to happen now is that we're simply going to have a function y is equal to sine x. And we already know how the trigonometric function looks like, is that it is going to look like this. All right. And the trigonometric functions are always, kind of like this. They're a wave and they go up and they come down. Pretty accurate. And we simply extend the graph a bit. So this is the graph for y is equal to sin x. And we already know how the graph looks like and everything. So for example, the graph is going to go at its peak at 1. It's going to go at its other peak at -1. Now, Parsa, considering the domain, like for example, the domain is given to you as 0, 2, 3, 6. Even if my domain was not given, Parsa, is there any chance that my graph for y is equal to sin x exceeding above what you may call 1 and -1? Yes, Parsa.
Can you repeat?
I'm asking you that, for example, for the given domain, y is equal to sin x is given as well, right?
Yeah.
Okay. I'm asking you, even if the domain wasn't given, or if there was any other domain given to you, still, would my graph had been going above, would a graph for y is equal to sin x go above 1 and -1?
No.
No. So regardless of what your domain is, regardless of what your domain is, some graphs are unique, right?
Yes.
Some graphs are highly unique, like this one. This
Some
graph is,
actually, like depend on the domain and the range. It
some graphs do not
depends
do.
on the equation.
Yes, it does not. The obviously the domain and the range will not influence the function. The function will influence the domain and the range. All right. So for a graph given as such, what do you think will be the range? Yes, Parsa. 1 and -1. Clear?
Yes.
So I can simply say that my range for the given function is y is less than equal to 1, greater than equal to -1. It doesn't really matter as long as, obviously, if there was a different function like y is equal to 3 sin x or some. But considering this function, you don't even have to go through all the finding out of the domain, drawing the graph, looking at the types. No, you just need to, use a bit of common sense and know how this graph looks on, your axis, and that will give you your answer. Clear, person? And this will be your range. Any questions regarding this person?
No, Mister.
Perfect. Now, what's going to happen is, one thing that you need to understand is that for the domain of a graph, oh, the domain of a function can influence the function as well. How so? Let's see. The range cannot influence it because the range is formed after, a certain domain acts on a function. The domain can influence the function. How so? Let's see. Consider a graph. I'll draw a basic one. F of x is, let's say, wait. Mhm. Did I use a general form above? No, I did not. Guess I'll have to use it. Y is equal to ax squared plus bx plus c. All right, person. This is your general form of a quadratic equation. Let's look at a graph of this. I'll draw a very generic one. Simple graph. And the turning point is also given to us. So the turning point is around here somewhere. And right here. Clear? And the turning point is H, K. Okay? All right. Consider the given domains. Now, if domain are given to you, if your given domain of the function says that, for example, it says that x is equal to all real numbers, then that means, Parsa, that your graph is what is going to be your graph? It's a many to one function, right? Is this clear, Parsa?
Yes.
It's a many to one function. Keeping this in mind, what's going to happen next? Wait, oh, what if I say that my domain is not all real numbers, but my domain is mm, x is greater than h. Now, Parsa, if x is greater than h, that means that considering this graph again and draw it again. Considering this graph again, I don't even need to look at this side of the other side of the graph. We're only talking about, that means whatever the graph is, we're only going to be talking about this guy, right? Right, Parsa? Clear?
Yes.
Because x is greater than h. Now, if we're only considering this part of the function, because this function is only as good as its domain, right? The function cannot go beyond its domain, right? That's kind of like the manual book with the device. Okay, you have to follow the instructions given in the domain to the function. Otherwise, the you cannot put anything into the domain, into the function apart from those values which are compatible with the domain. Now look at this graph only, person. Doesn't this look like, now forget about the rest one as well. We are not going to be even considering the other guy. So if I forget about the other guy, if I forget about this part of the graph, wouldn't that, make this entire graph what you may call one to one? Yes, Parsa. Hasn't the graph all of a sudden become one to one?
Yeah.
It has, right? So this is how your domain can influence your graph. This is how badly your domain can influence your graph. From being a completely normal graph to now to a many to one function in the beginning, where all real numbers were allowed. Over here you can say, many. Oh, writing with a dotted line. Many to one function over here. Many to one function over here. Now it has become one to one. Clear? And this can happen the other way around as well. How can it happen the other way around? Let's see. For example, what if you're given the graph is x is less than h, less than equal to h? What will happen then? Again, it will become many to one. Is this clear, person? How will it become many to one function again? Because of the fact, like we'll see what will happen now, that it is going to become one to one. Because now the entire graph is, we're only going to be looking at the left side of the graph. Clear, Parsha? Parsha, can you hear me?
Yes, Mister.
All right. Written this down, Parsa?
Yes.
I'll post the notes after this as well. So even if you've not, you can then. So this time around, we're just going to be looking at this side of the graph. So you can have it over here. Same graph, two different domains, and all of a sudden, the graph's type has been changed. Clear, person? You can clearly see. Any issues with this person?
No, Mr.
Now, one thing that you need to know regarding this is that, for example, what's going to happen now? Your domain of the function, your domain of f of x is equal to the range of your f of inverse. All right, the inverse of x. So it's because it's in the name itself, inverse. So it's the opposite. Domain of your function is the range of its inverse.
Yeah. So, like, Mr.
Yes,
Uh,
person.
for like inverse functions, it's the opposite.
Yeah.
Like the domain of the normal function becomes the range of the inverse, and the
Hmm.
range of the normal function becomes the domain of the inverse.
Yeah, yeah. It's the opposite way around. You're absolutely right. Now, the range of your normal function or your original function is going to be the domain of your inverse because it's in the name itself, inverse. All right. Now, one last thing that you need to know before we move on, which is graphical representation of inverse. What is inverse on the graph? What does it stand for? So, graphical representation of inverse, which is also oftentimes displayed like this. Now, because it's an inverse, it's completely the opposite of what your original graph should be. Completely opposite. Then the only thing that comes to my mind when I say the word completely opposite is kind of like a mirror. It is equal to me, but it's completely opposite. My right hand becomes my left hand in the mirror. So what happens? They are both equal but completely opposite. The inverse does nothing to the magnitude of the function. They are both equal in nature. They're just opposites of each other. So it's simply going to be whenever you're trying to draw or you're trying to graphically represent an inverse of a function, you're just trying to reflect, or you can say reflect in the line y is equal to x. So any sort of representation of an inverse on the graph is just a reflection of the original function in the line y is equal to x. Clear? So you're just going to reflect the original function in the line y is equal to x to get the graph of your inverse of that particular function. All right. Is this clear, person?
Yes, Mr.
Original function. reflection in the line y is equal to x of your original function. And y is equal to x is what? Your line of reflection. Clear, person?
Yes.
Any issues with this at all, person? Anything that you do not get?
No, mister.
These questions aren't that hard. Functions is probably one of the easier chapters in A level math. Okay? Anything that you don't get, person?
No, mister.
Okay. Let us see now. Okay. Let's try to write down a function f of x is equal to x squared plus 2x plus 3 or minus 3. Okay. Now, hopefully, there should be a way to write down the inverse, shouldn't it? Can I get an inverse graph? Hmm, there should be calculus, no, stats, no, parametric, polar. Hmm, Wait, person, I think there should be a way. Oh, wow. Oh, I'm such an Indian person. Why don't we explain it using this? Y is equal to sine x. Okay. And the other graph can be y is equal to sine inverse of x. Okay. Notice just this part. And I'll write down the line y is equal to x. And this, we can make it dotted. Okay, look at this person. The middle line, that's the middle line, and look at the inverse. The red line is the inverse, and the orange line, it's the original line. You can clearly see that these two are absolutely identical to each other, but the inverse is a mirror of your original graph. They're both being reflected in the line which is running through the center, the blue dotted line, which is y is equal to x. Clear, Parsa?
Yes.
So, any issues with this, Parsa?
No, mister. No issues.
That wraps up functions for you. Clear? But
Yes.
there is one slight topic left that you need to do, just one topic more, and after that we can do questions. Is composite. Now this is probably the easiest part of all the functions. You know better than I do that composite functions are probably the easiest. So you've done this in IGCSEs as well before. Just judging by the name itself, it just says that composite functions are the composition of two functions. All right. So composite functions are, we can say that, okay, let's begin with an example. So there's a question, this was a past paper question, that there's a function called or written as f of x is equal to fx minus 2. Okay, easy example. And this is the given domain. And there's another function, g of x which is 4x squared minus 9, and the domain is that x is greater than 0. Clear, person? Any issues with this?
No, sir, no issues.
The question is pretty straightforward. Two functions are given to you, two domains are given to you.
So you basically do like fg of x.
Hmm. But I'll add one slight part to this question. First, I want you to find the range of g of x. All right. Now, how do you find the range of g of x? You
You
simply,
complete the square.
yeah, you can go do completing the square. Or what I would do is that find the turning point. I
Do
know that it's going to be a
differentiation.
minimum point. So the minimum point, why? How do I know that it's going to be the minimum point? Because the graph is opening upwards. Why is it opening upwards? Because the coefficient of x squared is positive. So because if the graph is opening upwards, the turning point is going to be at the bottom. So the turning point is going to be at the bottom, and hence because it is at the bottom, you're going to have the point as a minimum point of g of x, which is going to be equal to what you may call. mm, Now, you can do it your way, Parsa. I have absolutely no issues with it. The turning point is, I'll do it like this. Okay. So dgx over dx, differentiation, which is equal to, now, how do you differentiate it? Power to the front and 1 minus from the power. So power to the front is going to be equal to 8x, and the constant term has no derivative. The derivative of a constant term is 0. And then you put your gradient is equal to 0, and that sorry, you put your derivative or your gradient function equal to 0, and that is going to give you x is equal to 0.
Yeah, and then Mr. You substitute your value of x to find the y value, the y coordinate of the turning point.
Yes, so it's going to be g of x is equal to 4 times 0 squared minus 9, which is equal to minus 9. So your minimum point or your turning point is equal to 0 minus 9. Oh, clear, Parsa? Now, your minimum point, is it in your given domain?
Um,
No.
yes. Oh no.
No, Parsa. Your minimum point, not in given domain. Not in oops, given domain. So because your minimum point is not in the given domain, what is going to happen? Hmm? You're simply going to put in the extreme values of your point into your domain into your function, and that will give you the range. So what is the extreme value of your domain into the function? So it's going to be g of 0 is equal to 4 times 0 minus 9 is equal to
-9.
minus 9. So that means that g of 0 is equal to minus 9. Therefore, your g of x needs to be greater than minus 9, and that should be your range. Is
Yeah.
this clear, Parsa?
Yes.
Any issues?
No.
So this is going to be your range. Clear? Very simple, very easy. Now, the second part of the question is the one that we're actually concerned with, which is the topic itself. Find the domain Find the domain of g f of x. But before we get to that person, before we get to all of this, let's just scoot on over to find out actually what is g f of x. Now, for example, taking these two functions again. Now, if it says in the question, find f g x or find g f of x, whatever it may say in the question, whatever function is written on the outside or whatever is written first, you're going to write that function down again. And instead of putting in writing that function down in terms of x, you're going to write that function down in terms of g of x. So what is going to happen? Your entire function f of x, instead of x, you're going to put in, instead of inputting in any value into x, you're going to put in the entire g of x function. Okay, let's see. So if it says f g x, it is simply going to be f of x, which is going to be what you may call 5x squared, oh, 5x minus 2. And instead of, now usually if it had been f of 2, then I would have inputted in into the function, into the value of x, I would have just written 2. I would have replaced x with 2. But now if it says f, oh, but now if it says f g of x, what you're simply going to do is, instead of inputting in any value into x, you're going to input in an entire function over here. Entire g of x is going to take its place over here. And how will it take its place over here? You're actually going to write it, not the notation alone. So f g of x is equal to 5 times 4x squared minus 9 minus 2. Is this clear, person?
Yes.
And then what's going to happen? If it's gf of x, gf of x is going to be what? Is gf of x going to be again the same thing? Gx, as it is, the function 4x squared minus 9. But this time around, I'm simply going to put in gf of x. So the entire f of x function comes into play over here. And whatever was happening to x in the original function, that is going to be the case again. So x was being squared over here. So the entire f of x function is also going to be squared over here. So in the end, it's going to be g f of x is equal to 4 times 5x minus 2 whole squared minus 9. Clear? And they're both going to have their own respective answers. Any issues with this?
No, sir.
All right. Now, if I want to find the domain of g of x, g f of x, how will I do that? It is extremely simple. How so? That it's simply going to be. Mhm. What is the domain of g of x? Oh, what is the domain of f of x? I think I wrote it as f of x needs to be x is equal to greater than 1. Sorry. Yep, that is what I wrote over here. Right? Yep. And what was the domain of g of x? X is greater than 0. Now, combining these two together, what do you think the newer domain should be? Yes. Yes, Parsa. What do you think the new? Mhm. Obviously, one function has a domain which is saying that it needs to be greater than 0. The other one is saying it needs to start from here. So obviously the second domain, the one that is going to be, because if you include the first domain, the first function will cannot be included until you know a certain amount of values can be put. So the domain are all the values which are compatible with the function. So obviously you need to include the values of the domain which are compatible with both, which is greater than 1. Is this clear, person? So it's
Yes.
going to be x is greater than 1 should be the domain of g f of x or f g of x, whatever it is. Clear? Any issues with this, person?
No, sir. No issues.
That is perfect. Clear? All
Yeah.
right. Now what's going to happen is that I can give you a few questions to do till our next class. Can you do those?
Yeah, sir. I'll try.
I'll give you an extension of these questions. Okay, we were doing this example. Now I'll give you another similar example according to this. But this time around, this will be a past paper one. So this is a past paper question. And it says f of x is equal to 3 exponent raised to the power minus 4x plus 5. X is part of all real numbers. And at the same time, what's going to happen is, okay, part 1, uh, A part I is state the range. Also, Parsa, remember always keywords are important. Now, if the question says state the range of f of x, and also it is of only 1 mark, the question. This means that no additional working is required. A bit of common sense, and maybe the question is very straightforward or to the point, or it is visible without doing. Because for a 1 mark question, he's not going to give you a lot of working. And it's also saying state. Usually it says find, solve, work out. This time around, they're just saying state. So that also means that the examiner is just asking you to write down the correct answer. He is not asking for an explanation. Yes. Then part 2 says find. Uh, I know you guys haven't done exponents yet, but I'll try to explain. Find f inverse and state its domain. And this part is 4 marks. Now, a hint I'll give you is that log of e, log of the exponent, is equal to 1. All right. So that if you can try and solve this, I know you guys haven't done logarithms yet, But if you don't solve it, it's not an issue, okay? All right, but do try it.
Okay.
And
So is that 3e?
yeah, 3e. Exponent, Barsha, exponent. On your calculator, it says exponent. And this is log of ln of e. Log of e. All right. If you're not able to, don't worry. We'll do the question in class. Then g of x is equal to x squared plus 5. This is part B. This is different. And h of x is equal to ln x. And both have the same domain, which is x should be greater than 0. Solve h g x is equal to 2. And this guy right here is 5 marks. All right, Pasha?
Okay.
Any issues with this? Mm-hmm. All right. Yes. I want you to solve these. In the next class, we'll begin with discussing them. Right, Pasha? Now, as always, I'll see you tomorrow. Bye, Pasha.
See you, mister.